Okay, this is 10.2 on variables and expressions. Before watching the recording, please make sure you have the 10.2 variables and expressions worksheet in front of you, as you need it to write down notes that I write down in the video, as well as you need a pencil and you need a highlighter. Now, 10.2 variables and expressions is an extension of what you learned in 10.1, where you were describing patterns, because this time what you're going to do is you're going to formalize your description of patterns by using algebraic expressions to represent your description of patterns. So there are a few vocabulary terms you need to know, so make sure you highlight these, and I'll go over each term. The first term is variable. A variable is a letter that represents an unknown number. So the examples I gave you were x and y. Those are the most common ones used in algebra. Remember, you can have any variable, but it represents an unknown. The next, in brackets, algebraic expression, or sometimes it's just expression. An expression is any single number or variable or a combination of operations, so addition, subtraction, multiplication, or division, involving numbers and variables. The key thing in an algebraic expression is that there is no equal sign. So the examples I gave you, you have 8 times t, or 8t, x plus 9, and 2y minus 7. Notice in all three of these examples, there is no equal sign. Equal signs are only reserved for equations. The next term is value. It's an unknown or calculated amount. The next term you may not be familiar with. It's called constant. It's a number that does not change. So it's obvious in the word constant. It increases or decreases the value of an expression. Finally, the last term, which again may be new to you, is called numerical coefficient. It's a number that multiplies the variables. So for example, let me just give you one here. You could have 5 times x, where 5 would be the numerical coefficient because it's the number that multiplies a variable x. Now, so those are the terms you need to know for 10.2. Now, the example we'll do together is from your textbook in MathLink 7 on page 359 if you want to follow along, but I've also copied the question over here. So, the example involves describing a pattern using a variable. So it says that a kitchen floor is being covered with red and white tiles. The basic design is shown below, or sorry, up here. And several of these basic designs fitted together make a pattern. So you have design 1, design 2, and design 3. So the first part of the question asks you to make a table showing the number of red and white tiles in the first 5 designs, and you need to describe the pattern. So I've set up a t-table for you, so you can, if you want to go ahead and fill it out before I go over it, you may feel free to pause the recording if you want to. Otherwise, I'm going to continue. So the number of red tiles, actually technically it's the number of black tiles that you see, because it's not, my diagram is not colored. So we're going to go with the number of red tiles. So I see in design 1 we've got 2 red tiles, or 2 black tiles. In design 2, we've got 4 black tiles. In design 3, we've got 6 black tiles. Now, we have to keep going. Even though we don't have 4 and 5, we can predict that because it looks like the number of red tiles is increasing by 2 each time, perhaps in the 4th design we'll have 8, and then in the 5th design we'll have 10. Now, with the number of white tiles, let's see what we have here. In design 1, the number of white tiles equals 10. In design 2, the number of white tiles after counting them through is 20. In design 3, the number of white tiles is 30. Okay. In design 4, I'm going to predict that the number of white tiles we'll have is 40. Notice that there's already an increase of 10 between each of the numbers of white tiles. And notice between here, between designs here, that the increase is plus 2 each time. Okay, so that's the pattern amongst the red and the pattern amongst the white tiles. So I'm predicting that with the white tiles, since it's an increasing by 10 each time, that you'll probably have 50 in the last design. So that's question A. So again, you're identifying the pattern. Now, question B asks, question A. Now, sorry, we have to complete this. So there are a few patterns happening. There's one pattern happening within the red tiles where the number of red tiles between each design increases by 2. The number of white tiles increases by 10 between each design, but there's also another thing happening. So the other pattern we have to identify, and I'm going to go to a different color to show you, is what is happening to get from the number of red tiles to the number of white tiles. What's the pattern happening there? Again, what is the pattern happening from red to white? Okay, now what we could do is I could look at 2 and I can look at 10. Okay, so think to yourself, what do you do to get from 2 to 10? What mathematical operation are you using? So from 2 to 10, 2 times 5 is 10. To get from 4 to 20, what mathematical operation are you using? 4 times 5 is 20, right? What are you doing to get to from 6 to 30? Well, 6 times 5 is 30. What are you doing to get from 8 to 40? Well, 8 times 5 is 40, right? And then what are you doing to get from 10 to 50? Well, 10 times 5 is 50. So you can conclude that the pattern is that the number of white tiles is 5 times the number of red tiles. Now, question B asks you to choose a variable. So I'm going to choose x, okay? X equals the number of red tiles. Okay, because it asks you in question B to choose a variable and tell it what it represents, because what you want to describe is how are you getting the number of white tiles from the number of red tiles, or what are you doing to get from red to white. Okay, now it also says to use the variable to write an expression for the number of white tiles. Okay, so the number of white tiles would be 5 times x. Okay, because again, the number of white tiles is 5 times the number of red tiles. 5x equals the number of white tiles. How do we know this expression works? Well, here's an example. Okay, again, if we go back to the number of red tiles here, if we had 5 times the number of red tiles, which is 2, we would get 10 white tiles. Here's another example. If we had 5 times the number of red tiles, which is 4, we would get 20 white tiles. So the pattern continues because we established in A that to get from red to white you multiply by 5. I'm actually going to rewrite red tiles as being x and white tiles as being 5x. So this is like your input is red and your output is 5x, or white. You may remember that from last year. Now question C asks, now actually what I'm going to do is I'm going to block out the expression we came up with in B because it's 5x. C asks you, I'll go back up here, how many white tiles will there be if there are 16 red tiles? Well, that actually makes our calculation easy. So we know that our expression is 5x, right? So if we know that the question is saying that there's going to be 16 red tiles, so we substitute 16 for x, because remember x equals the number of red tiles, we get 80. So therefore, there will be 80 white tiles. If there are 16 white tiles. So I'm going to go back and review what we just did. Okay, the first thing we did is we made a t-table, basically outlining the pattern of the red tiles to the white tiles in terms of the design numbers. We identified 3 patterns. We identified the pattern within the red tiles, or the X values. We also identified the pattern within the white tiles, or the 5X values. But really what we're after is the pattern going from the red tiles, or I'm going to jot down here as a reference the input from last year, okay? And then the white tiles is the output. So remember, what are you doing to get from the input to the output values? We determined that it was times 5 each time. Therefore, the number of white tiles is 5 times the number of red tiles. Question B asks you to choose a variable and state what it represents. Well, our variable is x, and that represents the number of red tiles. So that's what's called the independent variable. Then 5x is the number of white tiles. And 5x is 5 times the number of red tiles. We tested that out by saying that 5 times 2, which is the number of red tiles in the first design, equals 10. 5 times 4, which is the number of red tiles in the second design, is 20. So we know that our expression works. And then C asks you, well, if there are 16 red tiles in a design, how many white tiles are there going to be? We've already established that the number of white tiles is equal to 5x. So we just plug in 16 for x because that's the number of red tiles, and we get 80. Therefore, you conclude that there will be 80 white tiles. Don't forget to review all of the terms we've gone over in this video, but make sure the key is the algebraic expression and how you represent the description of patterns you identify.